So yeah, this is the actual presentation that I have prepared for today. So hello everyone, I'm Wing Ai. I'm a research developer working in TU Delft on the Graphalytics project. So last year we have presented our benchmark design of Graphalytics in an article accepted by LDBC 2016. And after that, we have been working on converting Graphalytics from a research prototype into a actual software product. And we have went through the alpha phase where we draft the first version of benchmark specifications, and we implement Graphalytics accordingly. And then we went to the beta testing where we actually tested our actual software in different environments. And now that we are at the final stage of the beta testing, then it's time to ask the question. So what can we actually expect from the release of LDBC Graphalytics? So that will be what this presentation is about. So Graphalytics in its core is a benchmark on the performance of graph processing systems. But the result of a single benchmark are just numbers that does not tell us any much. So only by comparison, by having multiple benchmarks, it is possible to derive meaning from it and to obtain new knowledge, to learn about the current state of graph processing. So that's the reason why we developed this environment, which eventually, when it is released, it will move to graphalytics.org. So this environment to actually encourage the stakeholders to share their results, and so that we can actually gain new insights of the current development. So there are four typical kind of actions that you can that a stakeholder can perform here. That's first is that Graphalytics will be hosting competition among graph processing systems for twice a year. So for those who are interested in the state of that results and to see which systems are currently active and performing well, then there's a place to go. And for an end user, it's important for them that they can download the Graphalytics software to do benchmark themselves and compare the results with what is being published here, so that they can understand what is the best system for them. And I think, as Alex already have mentioned, that you as a system developer, you'll be able to extend Graphalytics and to add your platforms into the benchmark, so that you and others can actually benchmark your platforms within the rules defined in Graphalytics. And finally, for vendors, that it is in their interest to impress potential users by participating in these competitions. Well, the competition itself is not that important, but it is what connects all the stakeholders together, and so that we get actually new knowledge of regarding graph processing. So it is important to actually have a fair and representative design of the competition, and that everyone agree on, but which is very difficult. And our approach is that during the beta testing, we are defining it into multiple rounds of competitions, and in each round we come up with a proposal of a benchmark specifications, and then we address the implementation and to see the competition results, and we take the feedback back from our collaborator, which are both from the academic and from the industry, to see that what are there to improve, and hopefully eventually we can reach. And when the beta testing is finished, we can actually achieve a consensus that it is actually a well-accepted benchmark design, and then it will follow by the official competitions. So the reason that you can see why it will take so long is that graph processing is a multidimensional problem. As Alex have mentioned, that you have to consider the variety in algorithms, in data sets, and in the system itself, which includes both the software and the hardware, the difference in there. So we will demo our approach here by showing you the latest results, and which is it's so-called the second round of beta competitions, and based on the benchmark spec of version 0.2.8. Sure. So, well, what you can see is that we try to reconstruct the competition in a number of smaller contests. And you can see that these contests are classified by the target scale, which is like small, medium, large, and XL. And also by various system quality, that's like cost efficiency, performance, scalability, and robustness. So from a perspective of an end user, that's most important thing for them is to actually look for the most suitable system setup for their graph processing workload. And what they will be doing is that, for example, they first need to identify what is the size of the graph that they have to deal with. That if that is in the scale of medium, then they should look for the system that's the best in that scale. And what is the best system? Well, that can be evaluated in multiple ways. And what we propose here is first the most important one is the cost efficiency. How much does it cost to have certain performance of a certain processing speed? And the second one is the performance. So what is actually the processing speed of these systems? And also the scalability when you want to consider whether you want to acquire more resources to process your workload. And the last is the robustness. That's how reliable is your system, how often does it fail, and is the performance actually stable, and things like that. As a vendor, then you can impress your potential users by entering in each target scale a competition, by participating in this competition. To show you example here, that's just a reminder that this is actually internal results, so nothing is really final. So, for example, you can see here there is a list of system that is entering the participations in the target scale small. And by the system under test, we actually understand it as the combination of the upper layer, the graph processing platform. For example, what you can see here is pgraph is power graph, OpenG, graph, and GraphX, etc. And also the underlying hardware infrastructure where it is running on. So, here you can see this result are submitted by us, the Graphalytics team. So they are often DAS5 supercomputer. So, but remember that is the user can submit any feasible combination of the platform and the environment. So once these results are submitted to our websites, then it will first be validated automatically to see that they are in the correct format. And then what will happen is that they will go through an auditing process to make sure that they are compiled to all the execution rules that are defined in Graphalytics. And when actually they satisfy all the requirements, then this result will be accepted. But we will also consider, for the accepted result, we will also consider, like, for example, abuse. Like some vendor may want to submit 100 results that they want their system in 100 different ways in their cluster. So that we will select the most representative results to be presented in the ranking. And the rest, they are still valid benchmark, and they will be unranked, so to serve as a reference purpose. And you can also imagine that your competitor may want to benchmark your software to prove that you're wrong. And depends on whether it is representative, that may be included in the ranking as well. So with this benchmark results, we will be able to construct competitions on the 4 system quality that we measure. The most important one is cost efficiency, but I will first present the performance because the cost efficiency is derived from the performance. And for the time being, we will not present today the scalability and the robustness because they will give you a better overview of the system, but it is not mandatory to participate in the competition. So, as we have mentioned that the Graphalytics benchmark consider actually the multiple dimension of graph processing. That's the difference in algorithm complexity and the difference in data set structure. It's not big enough. Okay. So yeah, so it is very difficult to come up with a mathematical model that actually can say that one system, when one system is in a higher rank than the other, then it must be better in any scenario. So what we have done is to take inspiration from ranking theory or pairwise comparison methods, where that frequently in sports competition like football or more intellectual competition like chess. What we have done is that for each system, we will benchmark them in 6 categories by the algorithms. That is BFS and PageRank, WCC, and the list goes on. That Alice has explained why we suggest this algorithm. So it is possible for each system to gain a certain amount of scores. And you can see, for example, the first one, the OpenG, that it is able to gain like 8 points in the BFS benchmark, and 4 points for also 8 points for PageRank. And so this point will be accumulated into a total, which we'll actually use to calculate the ranking. To show that how we actually assign scores to this each of these algorithm benchmarks, you can take an example here. That is so that for each algorithm, then in this case you are seeing BFS. That we have benchmarked it with a different type of data sets, either real-world data sets or generated by a synthetic generator, for example, DataGen. And then for each, if you see that each column, that we are benchmarking BFS on a data set called totally. And for each of the system, we do a pairwise comparison, so that that if you are better than the other system, that your processing speed is faster, then you will get 1 point. And if you are not, then you get 0 points. And if there's a draw, there will be each gets 0.5. It may sound complicated, but if you just look at this visualization, that is that if you see the best system is when the chart is full, then it will beat the other 4 systems. And remind that the last one is actually not participating. So, so that it will get 4 points. And you can see the second best system will get 3 points because it is better than 3 other systems, and so on. And the last one, it cannot gain any point because it is not better than any system in this scenario. So we repeat this process for different type of data sets, so that you can actually, may not in this case, but in some other cases, you can actually observe that these are not always in the same shape. That sometimes one system is better to process one data set than the other due to the structure of that data set. And so that by combining the points you can gain, then you get a score for that algorithm, and eventually that will accumulate to the total score. So we think this approach is better than, for example, taking the average of all the scores and then doing other average over all the algorithms, because actually every point you gain here actually has a meaning that is you are better than other systems in a specific setup and in a specific scenario. That is and if you see that the different algorithms like BFS, you can expect something to millions of edges and factors per second. But for something like LCC, then it may be 0.04 million of edges per second. There is a huge difference in huge difference in the performance processing speed, which some approach, for example, to take the average does not really make much sense. So, so in this way, we are presenting our what we're trying to show is to find out what is the setup that leads to the most state-of-the-art performance of graph processing. And so that may be not realistic for actually some of the end users because, well, I mean, if you don't consider the scalability, then actually the one with the better hardware might win. So, well, so that leads to actually the quality of the system quality of cost efficiency, where we also normalize the performance by the amount of by the cost of actually the software and hardware infrastructure. And here we only take, for example, a very naive approach that's one machine is $1,000, and if you have 16 machines, that will be 16,000. But eventually, we will be going to adopt the uniform cost model that is currently being proposed in LDBC, and to use that to actually to define our cost efficiency metrics. And you can see that it's not always justified to actually use more machines because it may not be cost efficient. So, okay, to wrap it up, then it is actually possible to, you as a vendor, you may wonder, how can I compete in this? Is that possible to perform well in both the cost efficiency and performance? And the answer is yes. So we don't, well, theoretically, we don't restrict the amount of benchmark you submit. So it is up to you to propose what is the best system setup, what kind of software you will use, and what kind of hardware and the quantity of the hardware you will use to come up with the cost optimum benchmark and with a performance optimum benchmark. So in this way, that it is possible for you as a vendor to be the best in both, but very unlikely to be in the same benchmark though. So, well, if you have, you're developing some cutting edge platforms and you want it to be tested, or you have some fancy hardware, don't hesitate to contact us. So that will be the presentation.
When you talk about vendors, who do you consider? Because for hardware vendors to showcase their new fancy hardware or supercomputers, okay. I think it's especially true with the Graph 500.
Yes.
But then it's also interesting to see the. So, for example, you said that only one entry per vendor. Per hardware vendor. Or
that is. This is a very important question. So what we have presented here is, well, more like a feature that we have the option to actually lot list when the fair use is actually being abused, then we have the option to lot list all the long representative benchmark in the list. But what we would expect is for that is considered to be cost optimum, and other one that is considered to be performance optimum, and also there will be reference benchmark, which you actually saw here, that will be unranked, that serve as a baseline to compare these software platforms on the same hardware. So that is currently our vision on that, but that could also be improved in the process.
May I add just that the vendor that we consider is the organization or consortium that sets the cost.
Okay.
And once you have that, there's a limit, software, hardware, and hard disciplines.
Well, I think the issue is right? So this is also an issue with LDBC. It's like, well, what's the price? You know, I think this is still unsolved. Right?
No, this is a hard. There's one for a long debate. The DPC benchmarks at least force some price to be out there.
Right. But I think it's a more mature space, right? I think that we should stay away from pricing while the market is not that mature. Because people don't even have, there's not even enough of a mature market to know what the right price is. I can tell you our product is not priced in any same way, which just someone came up with a price. Right? And when there is going to be more of a market, then the prices will be more same.
That's what's so exquisitely vicious about Jim's great pricing idea. It forces the vendors to get on with it. And you can put your price up high and then screw you. Put it low and it'll screw you another way. It's like there's no escape.
Does that mean that only commercially supported software packages are allowed? Because with open source packages, right?
Well, then you still have to count the cost of the hardware.
Is that infinite?
Yeah.
I think we can maybe have this discussion
Yeah.
after the pricing talk.
But it's vicious.
Oh, okay.
It is vicious, so you can see the pain.
Include the average discount.
Very well. Any other question or remark? Do we think this is a fair way to assign rankings?
It's interesting.
Yeah, interesting. I see nods. That's a positive perception. No people saying this is unjust or just because I lose a match.
And how about scalability? I did hear that scalability was self.
It will. Our current discussion is that the scalability will be evaluated, and there are many work to actually evaluate scalability. But it's very, very difficult to say that, given any circumstances, that one system have a better scalability than the other. So what we plan to present is a evaluation, for example, the scalability curve, but in the full picture of the system, then they can be able to see those results, but they does not contribute to the ranking.
So unless the denominator is the best single-threaded performance, what's the value of scalability?
If I may ask this part, organizations will provide the other denominator by putting the same environment. So DAS5 is a distributed multi-cluster system in the Netherlands, and that's going to be the denominator. So it's going to be the same. Whether it's the best that you can get in a sequential implementation, that's another discussion.
The environment is